All right, so we welcome you guys back from spring break. Hopefully you had a good Easter, and we're going to jump right in where we left off. If you remember, lesson 12.1 was graphing coordinates using the x and y axis. And so I'll warn you, today's lesson is going to be a little bit more boring and less exciting, but it's going to put into practice those skills and strategies we worked on in 12.1. All right, and a quick review, and this is going to come into play today, is our coordinate axis are these 2 points, right? Our x is first and our y is second. All right, so this is going to be a major part of what goes on inside of these problems. So again, you have to understand that. All right, so this is the two most important terms of this lesson. It is the independent variable and the dependent variable. And as you'll see here, as they describe in the paragraph form, the quantity that depends on the other is called the dependent. So it has that vocabulary again. This depends on the other. And I'll give you guys a little hint. This is the most important part of the lesson. And this is how you'll remember it, is the x is always going to be the independent, and the dependent is always going to be the y. And this is how kind of a fancy way to remember it is think of your ID. Your ID lets you get into places, right? And if you do it in the opposite order, it would be DI, which doesn't really exist if you want to use figuratively, right? That means that's not a good thing. So this is how you remember the order, all right? So the independent comes before the dependent. So you need your ID to travel. You're going to see in a minute a lot of these graphs of independent versus dependent have, function graphs that kind of look like this that go up, and they're all about traveling. All right, so you need your ID as you guys get older, and your driver's license, your driving ID in order to travel. All right, so that's the way how you remember it, is the I is the X variable and the D is the Y variable. All right, so let's take a look at this example now. One of the two quantities in this situation, a freight train is moving at a constant speed. The distance in Y miles that the train has traveled after X hours is shown in the table. All right, so the two quantities are time, hours, and distance. All right, so if you're taking a train trip across the country, right, after 1 hour, you would have traveled 50 miles to etc. All right, so this next question is important. Which of these qualities or quantities depend on the other? So it goes back to our equation, right? What's the independent? It is time x, all right? So the more time that you travel, the more time that you're in the train, the farther distance you're going to go. All right, another way to look at it, if you don't travel any time, you're not going to have any distance. And so the distance depends on the time. So that means the time is the independent variable. All right, so time is independent, dependent is distance. And now how far does the train travel each hour? So you'll see it there. These are going to be relationships and patterns now they want you to see that jumps out at you guys. You see we're counting by 50s. And so the train travels 50 miles each hour. All right, so let's take a look at the reflect part. How does the value of the independent variable relate to the dependent variable? Is the relationship additive or multiplicative? All right, so if you're adding, you'll see that in a second. All right, in an example that we have, if you add like the number 5 to each, that would be an additive property. But here, since we're counting by 50s, all right, we're adding 50 to each, and that is like timesing by 50. So that would be 50x is the rate. All right, so that is a multiplicative property. And what are the units? We just saw that there. It was hours to miles. And what is the rate? I just said that. The rate is the pattern, what it's counting by. So it's 50 miles per hour. And that should sound familiar to you guys. That's how cars drive. For the most part, speed limits are based off of that unit. So here we go. Here's some practice. All right, so we're going to identify the variables from this word problem. An art teacher has 20 pounds of clay but wants to buy more clay for her class. The amount of clay X purchased by the teacher and the amount of clay Y available are shown on the graph, so take a look at it. All right, so what is our starting point? Our starting point is not in the origin 0, 0 there, right? Our starting point is 20 pounds of clay, so that's what she's starting with, and that's given to you right away. And so now what happens now is that's where you start. Now look what happens. all right, is going up, right, by a certain number. Take a look there. What's in between 20 and 40? That's a 10, right? So that would be a little 30 there. And it's going over now also by what unit? So go from 0 to 20. In between, half of it is 10. All right, so if the teacher buys 10 more pounds of clay, how many pounds will be available for the class, right? So we started where? We started at 20, and now we're going to add another 10 to it, right? So that's basically an additive relationship, right? And so now we have 30 pounds. And if our class has a total of 50 pounds of clay available, how many pounds did the teacher buy? So what they want you to do is go backwards into it, right? So we find the total available here is 50, right? And so where is the 5? The 50, it's how many times over? So it's 1, 2, 3, 3 times over, right? Sorry, I don't have a small enough writing utensil there to blow that up right now just for you guys to see that, right? So it's 3 jumps over, and the reason why it's 3 is because we started at 20, right? So we started at 20, and then we went 10 more, 10, and 10. All right, so that's our 3 jumps, and that is how many pounds of clay did the teacher buy was the 30 parts there. All right, so what do we have here? We have reflect again. How are the same units are used for independent and dependent variables? How is it different from the situation using the train? If you remember the train, right, it was going up by, started at 0, and then it was going up by the rate per hour, right? In this case, we started at 20, and whatever the person added in now is adding into that starting point, so this would always be 20 higher than the amount bought by the teacher, so that was added in there. All right, so that's what you guys need to think about, right? And there's our equation there. It's y equals 20 plus x, so whatever the teacher bought, you'd have to add 20 to it. All right, so it's important for you guys to know the difference between an additive relationship and a multiplicative, which was what we looked at before. So let's look at this example. All right, so we have a table showing a relationship between the two, right? When x is 0, we have 10. And then as we move up now, it's going to be affecting the total there, as you can see, right? So if you wanted to graph that, right, at 0, it would be, I'm going to give myself a little scale, right? So there would be 10. All right, so now when I go over 1, 2, and 3, what am I going up by? You can see it's not going up by a lot. It's just going up by ones. All right, so there's 1 is 11, over 2 up 12, and over 3 up 13. All right, so there is our relationship there. We're adding 1 each time. What is our independent value? All right, and so now they're going to want you guys to think about what are some real-world examples on what this would mean, right? If you started with 10, and then if you go up by a certain quantity, what would the total be? So you guys need to think of something in the real world now. I would always give you a hint. I always think in terms of money. How could you start in a relationship or in a situation with $10, and then after 1 and 2 and 3 go up by that certain amount? All right, so good terms is money in the bank, right? So let's say that Jeff starts with $10 in his bank, and then his friend will give him $1 for every hour that he helps him with his math, right? And so that way you would add $1 every single hour, or maybe not in terms of helping in terms of math or whatnot. His friend will give him $1 for every one of his Pokemon cards. I don't know if you guys were ever in the Pokemon craze. All right, so every card that he gets is additional $1. How much money does Jeff have? Then you would take the number of cards, times them by $1, and then add back to the original $10. Right? So this is a breakdown of that as an increase by 1. Y increased by 1. The relationship was 1 because we're adding right to what we started with. That's an additive relationship. You can see that the GoMath example here is Gina in her savings. She started with 10 and adds $1 each day. That would have been a good way to look at it too. How about this one here? All right, so let's take a look at these two, and then let's think about real-world examples. So let's determine what's going on in between there. What do we have from 0 to 2? What's in between? It's 1, right? So it's going to be counting by 1s on the bottom. Now let's take a look at our increase at the top. We go from 0 to 12, right? What's in between 0 and 12? What's the halfway point? That would be 6, right? So we're adding by 6s. So we have 18 there, and then we have 24 plus 6 is 30. So now let's take a look at what's happening. After 1, we have 12. After 2, we have 14. All right, so what we're basically doing is making a little table here, right, with our x's, and then on the top we're putting the points. All right, so for the first point it was 12. What was the second point? Over 2, up 24. Up over 3, up 12 more, 36. So there's your 12 times tables, correct? So now a good everyday math example would be, how do we use 12s a lot in the world? And so what's something that comes into 12? Hopefully you guys can think of that, right? A dozen, what is the most common thing that is bought as a dozen in the real world? And that would be an egg carton or any other type of dozen. If you guys go to Dunkin' Donuts, you can buy a dozen donuts, right? And so that's what's happening here. You could say each day of the week a family member buys a dozen donuts or a dozen eggs. How many eggs will they have after 4 days? That is what they're using there. All right, and here's GoMath's example of that. You can see the number of eggs in the carton. All right, let's look at our thing. Our x is going up by 1 again. That is our independent variable. And then the number of eggs that you have is going to be depending on the number of cartons of eggs, which would be the bottom, right? So it's times 12. That's a multiplicative relationship. All right, let's take a look at this one, and then let's use what we just talked about. Describe a real-world example on what's happening here. So when x is 0, look at what y is. So if that is our graph, right, what would that mean when x is 0? That's the starting point, right? It's not 0, 0. It would be 0 going up 15. So 15 is the starting point, all right, and now when I'm going up now using my x, using my independent variable, what's happening now to my numbers? Now I'm going to have 16, 17, etc., right? So what they want to know again, they want to know the type of relationship is it to go from here to here to here. What is that called? That's an additive relationship, right? And now we need a real world example, all right? Our starting point is 15. All right, so go back to that example we just heard from Gina, right? Gina starts with $15 in the bank, and every week she is going to put $1 savings into her account, right? So this week she added $1, this week she added $1, and so you could use that now to say 5 weeks from now, how much money would she have in the bank, right? So you would start with the starting point plus the 5 weeks of $1 each, and then you could get your answer. So that's how you use the independent and dependent variables. One more example here. All right, so let's think of our graph again. Where do we start? 0, 0. That is our origin. And now I'm going, where's my independent variable? My x. And what's happening now? All right, so I'm going up by, take a look here. Do we have a pattern? Hopefully you guys can see that. If not, take the first two numbers. Whoops, 16 minus 0 is 16, right? Now see if that's a pattern. What's 16 plus 16? 32 it is. And so that is what we're going up now. We're going up by 16s. All right, so what's a real-world example of that? So try to think of something where somebody gets 16 for doing something, and that would be, let's say somebody gets paid $16 to help somebody clean his yard or to paint his house. How much money would he make after 3 hours? All right, so that would be $16 an hour times 3. All right, so regroup the 1, that would be $48. All right, so independent variable again, here would be time, right, or days, depending on what it is. And the more time that you have, the more money that you make, and that would be the dependent variable. So independent and dependent. All right, one more example here, real-world example. What do we have here? So take a look at our starting point. We have zeros. Now let's see what we're going up by. What are our units here to go in between 0 and 2? There's 1 in between, so we're going up by 1s. Now let's take a look here. Right now it looks like it's going up by 1s, but is it? What's the difference between 0 and 6? Halfway mark would be half of that, right, which is 3. And now we're going up by the same rate. So 3, 6, what's the next one? Take a look here at 3. It's there. That would be 9. All right, so our rate is 3. So that means our Relationship is multiplicative. And now we need an example that connects to this, right? So think about it. Here's my little table. So after 1 I have 3, 2 is 6, 9, 12. All right, let's use this in terms of online math work, right? So in 1 hour of work, the student completes 3 assignments, 2 hours 6. How many assignments does he complete in 5 hours? That would be one example of how to do it. So the x variable, the independent variable, would be hours, and then the number of assignments he or she completes is based off of the dependent, depending on the hours, and that would be the y variable. The dependent would be assignments completed. So whatever you want to say, it matters not, just so it connects to the problem. Okay? One more example here. A lot of examples, like I could say, and I told you guys this wasn't going to be exciting, so I did warn you. All right, a boat rental shop rents paddle boats for a fee, plus an additional cost per hour. So the cost of renting for different numbers of hours is shown in the table. All right, so let's take a look there. What is our starting point? Our starting point at 0 is $10. So it costs $10 before you even begin, and now an hour later, 2 hours, 3 hours, that's what your cost is going to be. What is the independent variable? So what is changing on the bottom, right? That would be hours. And what is the dependent variable? That would be the cost. So the cost is based off of the hours, all right? So if they don't spend any hours, all right, if you don't even show up, there's not going to be a cost, right? So the more hours that you spend, when that goes up, the cost is going to go up. So that is why the time is the independent. The cost depends on it. All right, a car travels at a constant rate of 60 miles an hour. Complete the table, right? So after 0 hours, how far did it go? I'll just give you guys a moment to complete that table. So I'll just give you a moment to complete all of this. So start with the table. How far did the car travel to start? After 0 time, it would be 0 distance, right? And then after 1 hour, we're using our 60. After 2 hours, you're going to add another 60. Hopefully you guys see that counting by sixes, adding a 0, right? So that would be 120. And then after 3 hours, we have 180 miles. What is the independent variable? That would be time. That would be hours. And then what is our dependent? Would be the distance, would be miles. How is the value of the independent variable related? So what is it doing now? It is going up by 60. So that is its rate right there. All right, so if you guys want to look at it in terms of an equation, it would be y equals 60x, with 60 times whatever number of hours there. Sometimes you'll see that written as an h in algebra, right? You could say that is distance as in d. All right, so hours, the number of hours equals 60, and that would be the distance. You could also say that's miles. All right, so that's how you use algebra to solve these. All right, and now one more example. All right, take a look at here, what's going on. Give you guys a moment to do that. Describe in words how the value of the independent variable is related to the value of the dependent. So take a look at our units there, what's going on. We are going up. What's halfway in between 0 and 10? Halfway point is 5, so it looks like our counting by 5s. Between 10 and 20 is 15. So what's happening now? After 1, we have 5. After 3, we have 15. So whatever you want to say, once again, real world example. All right, let's keep time on the bottom. So let's say days is on the bottom. And then what do you want to say on the left? Let's say money. Right? So what happens? Real world situation. So a student saves $5 a day. All right. So what's the dependent variable? Dependent is money, and it depends on the number of days. All right, so that's how you always think about that. The dependent goes up based off of the independent variable, what's ever happening going across. So there we go. This is what you guys are going to do now, is you're going to practice. Again, a lot of different explanations between the difference between independent and dependent. So please remember, again, what I said. So we have ID, independent is always the X, and the dependent is Y. So again, look at the rate of changes. Is it just by adding something to a total, a starting point, or is it counting by the same number, which would be a constant slope going up? All right, so let me know if you have any questions. Otherwise, we'll get this done and we'll be moving on.